Nati is here. Perfect. Wait, Nati's the wrong class. Okay, Nati, are you in period 1? No, you could stick around if you want, but you're supposed to be in period 1 right now. All right. Okay, so let's see. Going back in the chat, I just saw one in the chat that had it for a book problem. So let me see which one that was. Okay. 2, 6, 9 in the book. Let's see if we can do all those. Number 2 in the textbook. 2, 6, 9. Perfect. So we have the same numbers we need. And we're looking at section 1 to 1. Right? All right. I think we're looking at this. Whew. All right. All right. So we're looking at this. We have. Gotcha. All right. No worries. All right. So we're looking at this, and we have a pen right here to work, I'm sure. Get it out. Sorry, guys. I'm adjusting to my new space again. Let's see if that works. 2 pencils in a row didn't work. Okay, guys. My bad. Nice. Okay. All right. So if we're looking at number 2 in the book, number 2, our number 1 just had our problems here. Number 2. Let's see. All right. So number 2, we're looking here. Let's see. All right. I hope this is exactly what we want. So first, we're just going to read it. We're going to look at the same process. We're just going to read it first. All right. The radius of a sphere is measured to be 3.12 centimeters. What is the most accurate volume of the sphere you can report? Is this the right? Yeah, it is. Okay, so it looks like we need the radius of a sphere is measured that. What is the most accurate volume of the sphere? Okay, well, we need the volume of a sphere. We need the volume of the sphere formula. And let me ask Siri, because I don't remember it. Siri, what's the formula for the volume of a sphere?
I found this on the web.
Oh, thanks. No, you didn't get it right. Volume of a sphere formula.
A sphere is a geometrical object in three-dimensional space.
Brett. Volume of a sphere formula, please.
I found 2. Left, vec, x, vec, x, vec, x0, 2 equals r squared right, and x squared plus.
Okay. Sorry, guys. This is one of those days. Thank you. All right. So we have our equation for the volume of a sphere. I want you to go and write that down. So for like the SAT, you're not going to have to memorize these kind of formulas. They're going to be given to you for the SAT. Okay. So I'll edit this video so it's a little more concise. Let's read it again. The radius of a sphere is measured to be 3.12 centimeters. So we know that the radius is 3.12 centimeters. So these problems were much easier than the other problems we did. These problems, I guess, we had to look up the volume of a sphere. But now that we've done that, we know what the radius is. What is the most accurate volume of the sphere you can report? So this is really going to be more of a PEMDAS type problem, because we have 4/3 times pi times 3.12 to the third power. Okay. So if I'm looking at that, we know that we have to apply exponent first. That third power is only applied to the 3.12. So when I go about doing that, I'm going to get 4 over 3 times pi times whatever 3.12 raised to the third power is. So I'm going to go in here and put in 3.12. And we're going to use this button right here. It's the one with the X to the Y. You might have a button that looks like this. It's a little chevron. The chevron is also the exponent button. Okay, so let's look at that. All right, Mia's here. We're going to raise that to the third power. And we have 30.37. Okay. Now what I'm going to do here is I'm going to think of this as a big fraction. Everything is going to be divided by 3. Because everything is multiplied together, I can multiply everything together, all these numerators. And remember, pi is just pi over 1. This is 30.37 over 1. So you can multiply all the numerators together and then just divide by whatever your denominator is. So let's go ahead and multiply. Where's my pi button? My pi button on this calculator is... There it is. It's really far back there. It's the second, and then behind there. All right, the other thing you could do is just to put in just a couple digits of pi times 4. So all the top is 381.42 or 44 approximately. Now we're just going to do all that. We multiplied all this together. So now we're just going to divide by 3 and we'll be done. And you probably could have done more accurate. For some reason the button for this, for pi, isn't working. But we're going to go with this. Let's see, centimeters cubed. Okay, so this is actually a pretty good like SAT problem. Okay, so in the chat, let me know if there's anything there that we need to slow down on. And sorry it wasn't that clean with getting everything in there. Any questions on that one? Go ahead and put it in the chat if you're confused with it. Okay. All right. Well, I'm really hoping that the next number goes a little better. All right. Curtis, how do you feel about that? Thumbs up, sideways down? What do you think?
I was just like a little bit confused. Like what numbers are right up to the equation. I didn't know what to write.
Yeah, it was just that this formula was on the top of your head.
No, yeah, I totally forgot about it.
Okay, no worries. And you know what? Don't worry about memorizing these. You'll have that reference for like the SAT. So I'm going to allow you to have some formulas if you need them for the quiz. Okay? All right. But the main thing is, remember that a formula just has different aspects to it. With the volume of a sphere, all you need is that radius. Okay? Remember, a sphere is just like a, it's like a ball. So if you have the radius of the sphere, then you know you could find the volume if you use the formula. And we just plugged in the radius and found it. There's probably a little bit more accurate if you used more digits of pi, but we'll go with that. Okay. All right. Let's keep going. We had numbers 2. Who was on it really quick? Somebody did it really quick. Natalie had a bunch. Good. All right, 6. It's always good. This was in the book. 1, 2, 1, number 2. And now let's do book. 1, 2, 1. Number 6. Okay. So we're going to look on number 6. And I think these are the ones that have a slightly different type of problem. Let's see what we have. Okay, let's read number 6. All right, first we're just reading it just to get an idea. Okay, so Rebecca bought X pairs of socks and received a 20% discount. Each pair of socks costs $4.99. Her total cost without tax was $23.95. How many pairs of socks did Rebecca buy? Okay, so remember, I like to do the little bullet points. So we have bullet points. Let's say you bought X pairs of socks. You have a 20% discount. Okay, each pair of socks is $4.99. Total. Remember, total is what we use, and we always put that on one side of the equation. All right, the question is, how many pair of socks did Rebecca buy? So we're looking for that. That's the main question. Okay. So just like before, I put my bullet points in here, and then I go and set up, okay, my equation. Now, what did I always say is going to go on the right side? Go ahead and in the chat. Go ahead and in the chat, let me know what always goes on the right side, guys. What always goes on that right side? Total, yes. So I know it's the total, it's the budget, it's the goal, it's whatever you're trying to equate. Okay, so we're going to go ahead and put the $23.95 over there. Okay. Now, if that's the total, the other things are going to add up to it. Okay, so let me know how much would one pair of socks cost? Here, $4.99, right? $4.99. So we did this. We're going to go ahead and put $4.99. But remember, we're trying to find how many socks we're buying. So I put the $4.99. I had to compare it or multiply it with the number of socks we're buying. All right. So this was, you could think of the subtotal. Then we're going to have some kind of discount, and that's going to give us our total. Okay. All right, show me on your hands. If you have a discount, are you going to add or subtract it from your subtotal? If you have a discount, good. I see a lot of subtractions, good. Now remember, we have to take 20% of our subtotal, which is 4.99x. Okay. So show me on your hands. What does of mean? Good, good, good. All right, good. So this as a fraction or decimal is 0.2. Of is multiplication. So we're going to go 0.2 times 4.99. Now remember, this is our discount. We took 20% of 4.99. So I take my subtotal, 4.99x, based on how many I buy. I subtract 0.2 and 4.99. So now we're going to take this and we're going to bring it down here so we can see it better. We get 4.99x minus 0.2 times 4.99. We're going to just do that. 0.2. Remember, it's okay to multiply terms that aren't exactly the same. These aren't like terms. Sorry. Add something here, right here. Add something right here. I'm going to add an x. I forgot to put the x in there. So it's 4.99x minus 0.998x is equal to 23.95. All right, now I want you just to combine these like terms. Go ahead and divide whatever your coefficient is left there, and that'll give you our x. So go ahead and work that out, then throw it in the chat when you're done. Throw it in the chat. All right, Abby has one. Curtis has it. Okay, and I think we're right about this. Curtis, can you round that? Can you round that? What would that round to?
I don't know.
5?
Yeah.
But it's 5.9. Yeah, I think it's going to probably round to 6. That's what someone else put. I just want to double check that real quick. 0.998. And then we're going to go. So this right here gives us 3.992 is equal to 2395. So we just got to divide that 2395 3992. Yeah, it looks like we get x is 5.999. So we're going to say x is 6. 6 what? 6 pairs of socks. All right, all right. So we had one more to do. I can only show you this last one if I just work it out. Okay. Oh, 9 in the book. I don't think that was our assignment, was it? Uh-oh. Let's double check. Maybe we are done. All right, I'm going to pause the recording real quick. Oh, nice. Nice, Remy. That sounds like fun. I like that kind of stuff. All right. Well, let's look at number 1. Number 1 is in the book here, and we're looking at those same situations where we have jogging. You know, we have these different situations, and we need to just. Oh, I'll let you know too. If you're done with all the homework and you're just coming to check in, then go ahead and tell me in. Right. Go ahead and tell me in the chat, and I'll go ahead and dismiss you. So let me know if you're going to work on something else. If you're done with all the homework, you just came to check in. That's perfect. Okay. Right. So Devin, you're free to go, and I will see you tomorrow. Anyone else going to be checking out? All right, good. Good job, Remy. Nice. All right, Jada. Perfect. All right, Nelson. All right, guys. So good to see you briefly. I'll see you tomorrow. Okay, great job doing all the homework quickly. And I will see you tomorrow. Thanks. Have a good day. You guys too. I like that. Good background too. All right, I'm going to jump right back in. Here we go. All right, thanks, Brooke. Thanks for letting me know. All right, let's look at number 1. Number 1 has the units we have to figure out. And let's do A first. So jogging, right? Jogging is talking about rate. We're going to try to first find our unit rate. Actually, we're just going to find our unit rate. So what is the unit rate for jogging? First, how do you measure how far you go? What do you think? Well, if I'm jogging, right, I'm going to probably be jogging. Yes, Elizabeth, you're free to go if you're done with the homework. All right, so we're going to have miles, right? It's just like when you're jogging and you're running, or you're riding a bike. So I'm going to say miles per hour, okay? Because if you're on a treadmill, you know, you're running, you're going to keep a certain pace. So we can call this miles per hour. That's fine. All right, B, the speed of a giant tortoise on land. All right. So it's a tortoise. That's like a big turtle. It's a type of turtle. So how fast do turtles and tortoises walk? Really slow, right? So I'm going to probably say this is going to be feet, right, per minute. Maybe in a minute it might go a few other feet. So this is going to be, it's about finding the unit rate. It's about finding what is appropriate for the situation, right? Because I wouldn't do feet per minute if it was like a rabbit. A rabbit's much faster. That might even be feet per second, okay? But we have to do feet per minute because I can imagine that the tortoise, right? The tortoise is going to walk, you know, this far in a minute. Maybe it can walk about 10 feet in a minute if it's moving really fast, okay? So I want to just keep in mind, what type of scenario are we talking about? Oh, this is a good one. Speed of light. So instead of a tortoise, so moving slow, now we have the speed of light, which is really fast, okay? And it's really interesting once you start studying physics, like how it actually works. But here we're talking about, let's see, the speed of light. We could talk about, well, they talk about light years, right? light years. You could talk about something really fast. So, wow, that's a tricky one. Well, they often talk about light years, not tight years. Light years. So with light years, we have miles per year. This one's kind of ambiguous, and you could say, well, or I could say, you could do, it's even miles per second. All right. So miles per year is light years. That's what that's going to give us. But we could also say that we're just talking about miles per second. You really have to think about it as, is it really, really fast or is it really slow? So miles is a good indicator of distance, but the time, you could do it in miles per year. That'd be light years. Or you could do it in miles per second, which is talking about just like, you shoot a laser towards a satellite, and the speed of electromagnetic waves are going to be the speed of light. So if it's through a vacuum. Okay, let's keep going. D, last one. Cost of mailing a package. Cost of mailing package. All right, so think about that. If you were mailing like your weight set, like your bench press set, all your dumbbells and dumbbars, all your weights, it would be really, really heavy, right? It'd be really, really heavy. So we would know that depending on how much your item weighs, it's going to affect the cost. So I could say that this is going to be pounds per dollar. The cost of mailing your package. So say if it was 2 pounds per dollar, okay? Then you could see that if I had a 200-pound item I was trying to mail, then it would be, since it's 2 pounds per dollar, it would be $200, or 200 pounds, so it would be $100 to send, okay? Because each 2 pound increment costs $1. So these are going to be, you'll have some like these that are really straightforward, probably more like the workbook, okay? So that's number 6. That's that's number 1. It's number 1, A through D. So I'm going to pause it because I've done number 6 on the video already. All right. So we look in the book, we look at number 3, and we have this problem here, okay? The length of a dance floor to be replaced is 1 foot shorter than twice the width, okay? You measure the width as 12.25 feet. What is the area and what is the most accurate area you can report? Okay, let's write down what we know. We know that, let's see, the length is, right? So we're relating the length and the width. Okay. So the length is 1 foot shorter than twice the width. This one's tricky. So the length is 1 foot shorter than twice the width. So twice the width would be 2W, right? But we're told that the length is 1 foot shorter. What is shorter? Give me the operation for shorter. What would shorter be? Shorter is just subtraction, right? So here's twice the width is 2W, but it says the length is equal to 1 foot shorter than twice the length. So what I'm going to do? Minus 1. Right? It's tricky how this is worded because it could be slightly different. There could be parentheses if it was worded differently, but we're just told that it's 1 foot shorter than twice the width. So we get this situation here, and then we also know that the width is 12.25. So this is a slightly easier problem than the last ones we've been doing, because now we have, essentially, we were told that, the length is minus 1 Oh, no. This is hard to express as bullet points, and I'm sorry about that for this problem. But with this, we know that the length is 1 less than 2 times the width. I know what the width is, so now I can just plug that in. 12.25 minus 1. So we end up with, this is going to be 24.5 minus 1. So we know that the length is 23.5. What was our units? Our units look like they're feet. Okay. I don't think I'm going to give you quite a problem like that. I like the problems that are discount, that are tax, because that's more relevant. These we're going to hit again when we get into solid geometry. Okay, I think that's more like unit 5 or something. All right, thumbs up, sideways down for this. Was it just different than you thought? It's kind of in the middle. This is why it's in the middle, right? Yeah, and that's where this is something we'll revisit with solids when we're more apt with these. Okay, so I don't want you to worry about this too much. Let's see. How about this? Take your age, right? And if I said that your aunt is 3 less. Your aunt is 3 less than 3 times your age. Your aunt is 3 less. Your aunt is 3 less than 3 times your age. Okay? So your aunt is 3 less than 3 times your age. We'll call y is you, okay? So we'll use the variable y is going to be your age. So if I say your aunt is 3 less than 3 times your age, whoops, then what I'm basically saying is your aunt is, let's see, 3 less than 3 times your age. So 3 times your age is 3y. 3 less than that is minus 3. Okay. I think if I did like 100 of those, you guys would get it quicker. What do you guys think? I mean, do you understand what I mean by that? So tell me in the chat box, how old is your aunt? Work it out. Tell me in the chat box, how old is your aunt? Nice. Okay, so 42 divided, wait, what? 42 divided by 3 is 13. Okay. Or 14. 14. Okay, so Jackie, you're 14? Yeah. 36. Okay, Nati, you're 13. Dylan, you're 13. Okay. So it's just relating two people's ages. Okay. Anyone else tell me how old your aunt would be? Okay. So Elizabeth, you're 14. You got it. You got it. All right, Tram, you're 13. See, I could tell just by that. There's some weird tricks you can do with that. All right, thumbs up, sideways down for that. A little bit better? Okay. I'm not going to give you one quite like this. I actually think that this is one of the trickier ways. Okay, almost 15, not quite. All right. 14 and a half, huh? Okay. All right. I think that's going to be it because we are at our time, I believe. What did I put in the chat? I said this. And hey, there we go. Yeah, we're already 2 minutes over. I'm sorry, guys. We're going to go ahead and end it there. Okay, this video will be posted